UNESCO revealed that 60% of the world's marine ecosystems are being used in an unsustainable manner or have been degraded completely. This study delves into the factors involved in habitat restoration, including causes of decline, with Zhu and Wang stating that over half of the wetlands in Europe and North America were drained solely for agriculture, with action already taken and the sufficiency of this. And lastly, future applications, as Nature for Climate reported 30 million hectares, roughly the same size of Italy, of degraded coastal wetlands has potential to be restored. Using resources from the Web of Science, we collate, manipulate, and analyse datasets and literature to answer the question of coastal restoration: where and why is it happening?
Planet Report 2020 stated the biggest drivers of change to marine environments to be fishing, climate change, coastal development, invasive species, ocean pollution such as oil, land pollution such as plastic and rubbish, shipping, and mariculture. On Web of Science, I combined coastal habitat degradation and each driver and then refined it to show only papers from Europe. This pie chart shows how the subjects were divided among the 83 papers I found. We focused our research into salt marshes and seagrasses. This graph, produced using data from Eroldi and Beck, shows the level of impact of different drivers on wetlands, including salt marshes, and seagrasses. They are rated from 1, the lowest level of impact, to 3, the highest. Seagrass health is very dependent on water quality. Land runoff, dredging, disposal at sea, and some aspects of construction work are all contributing factors which can alter ocean salinity, pH, and temperature. They can also contribute to organic matter suspension because of these chemical changes, or by physical matter, which reduces the level of light reaching the plants. Coastal development has huge implications for both habitat types as it creates multiple degradation factors. Habitat loss, drainage, and increased erosion due to hard defences are among the most obvious. I produced this diagram to illustrate the anthropogenic factors of coastal degradation. It can be hard to quantify the damage caused by human practices, as there are little to no areas which are completely unaffected. However, we do know that these practices are accelerating the rate of change, and that's also a problem. In areas which have seen the most degradation due to these anthropogenic accelerators, we have researched current and ongoing projects focused on restoration to assess the most effective strategies.
My specific aim for this assignment was to investigate what coastal restoration has taken place and the reasons why. Before exploring this issue, it is important to consider the reasons why restoration is necessary in the first place. It is becoming increasingly important to restore and protect coastal ecosystems. This could be due to the increased degradation taking place because of human activity, as well as the fact that coastal ecosystems offer significant protection to the coastline. In order to collect primary data for this assignment, I conducted a Web of Science search for coastal habitat restoration projects and recorded the number of articles that related to seagrass, salt marshes, mangroves, and sand dunes, respectively. I then collated this with secondary data sourced from scientific journals to produce graphs and tables in Excel. Figure 3 can be used to compare the percentage of research papers concerning each coastal feature to the percentage of restorable coastal land that is covered by each of them. It can be seen from this that seagrass takes up the majority of restorable land at 59%. Despite this, only 14% of published articles were about them. Studies have shown that restoration of seagrass beds is usually more expensive when compared to other ecosystems. This can help to explain why there are less projects being taken up than expected. As well as this, salt marshes are the most written about feature in this study, despite only covering 7% of actual restorable coastal land. This would insinuate that there is a benefit to salt marsh restoration that makes it a priority over other features. This is likely due to the fact that salt marshes provide an atmospheric carbon sink, making salt marsh restoration a key tool in tackling climate change, an increasingly important issue in recent times.
Establishing whether the restoration of salt marshes has been successful or not is not as easy as a yes or no answer, as there are various ways one could measure success. Evaluating success is not only important because it shows what the project is set out to achieve, but also helps restoration practitioners to further improve future projects. Saturation index is one possible method in which the presence of target plant species in a restoration site is expressed as a percentage of a regional species pool. This can be seen in Figure 1, where changes in the number of target species in the restoration site in South East England are shown. This specific site did not see vast improvements in plant species till 5 years into the project, with a 30% increase compared to the first year. This shows a slow and prolonged process that emphasises how you may not see benefits in habitat restoration immediately, as these take time. The northern Gulf of Mexico proved to be a place of successful restoration, firstly with a steady increase in a total vegetated area per metre squared plots in the first 1.5 years after planting, with bold predictions, with these shown in white, showing a sharp increase in the following 18 months. This interlinks with a sharp increase in biomass as organisms have an increased area for an ecosystem to prosper, and this can be used to evaluate habitat restoration success in terms of the ecosystems it can provide. In the Gulf of Maine, salt marsh monitoring datasets from a total of 36 complete and near-complete projects were compiled to assess restoration practices and regional monitoring. Figure 6 shows an increased tidal range compared to prior restoration, with Figure 5 showing an increase in salinity levels, giving the salt marsh more favourable conditions in order to be successful, as high tidal range marshes are more stable as well as being more resilient to sea level rise. Results from the American Geophysical Union showed there was a correlation between enhanced stability being attributable with vegetation growth range that expands with tidal range.
Hi, I'm Soph and I'm going to be going over the consequences of coastal restoration and projects on the salt marsh community within Europe. As you can see in Figure 1, it shows how I have sourced and collected the total papers researched, relevant and being used via the Web of Science, extracting the data through Excel and collecting the data analysis to give you the graphs and tables shown ahead. So in Figure 2 is a global worldwide map of the total net loss of salt marsh community as a direct impact of coastal restorational projects, with China, America, the UK and Canada being the most impacted by this. However, in Figure 3 it shows the difference between Europe and global, with a 30,000 hectare difference in the loss of the salt marsh community worldwide. So in the grand scheme of things, 30,000 hectare mean difference between the Europe and the world is actually a very big fraction of the world's total loss of salt marshes, considering Europe is a very small fraction of the world. However, in Table 1 shows the locations of the world against the keywords that are most impacted in these papers that I have searched and the most relevant to my objectives, such as agriculture, industry, residential, recreation, land conversion and reclamation. As indicated, I have created a Y to show the locations most impacted by these. However, in Table 2 also shows the future applicational purposes for the coastal restorational projects for the salt marshes in the future, with the authors running down the left-hand side and the keywords such as drivers, experimentations, management schemes and more. Again, with the Ys indicating the areas that need to be focused on for the future of our salt marsh community. Thank you.
Overall, we think that more restoration projects are needed to return salt marshes to more sustainable levels. This needs to be of particular focus in Europe, as this area has some of the largest losses. The techniques in the projects we've found have generally created positive results. However, there needs to be greater consideration of restoration in the long term and how to maintain salt marsh health.